So far, we always just wrote code, tried it out on a debugger, or just ran our code and hoped everything worked. And if not, we just tried to figure out why and how, using the debugger usually, and fixed it. But the larger your code gets, the more difficult this will become, because the more code you have, the more options you have to run the code, the more variations you have when running the code for different ifs and loops and whatnot, and different inputs. And also, the larger the program gets, the easier you will by accident break existing code, maybe indirectly without even knowing it. And so even though the code you wrote previously was perfectly fine and safe and did exactly what it should, now the old code you were thinking is good is suddenly broken. So you can't even rely on the existing code that was already proven to work to still work. And that's a big issue, because a lot of programs are pretty big. And of course there are ways to mitigate the issues. And we're looking at a big option today. First, we are gonna create a program, as I usually do, because I think writing them on stream is more interesting than just looking at code directly. Plus I can fill time. Let's create a player, not a player. Player. Should focus on typing instead of reading. I lost track. Public. Let's do public int attack power. And we can set the attack power from inside constructor. So we can create a new player. With an attack power of 10 maybe. And we need something to fight, so we'll add class monster. And monster is gonna be a bit different. We're gonna have an integer maximum health. Max. Let's just use max. Okay, see, one of the reasons I started streaming again was to get more practice speaking English. I think it worked, looking back. Was pretty rusty, but still needs so much more practice. Public monster. And we're gonna give it current health and max health. Oh, autocomplete doesn't... No, okay, didn't get us. Okay, this time it did. Still not sure what the rules are for it to understanding what I want, and sometimes it doesn't. It's, well. And then we're gonna create a monster. Monster. We're just gonna have, let's say 100 health. Oop, not like that. 100 health. 100 of 100. And let's help us a bit with the debugging. Debugger display is gonna have... no, that's current health. That's out of max health. That should be it, right? Is it? Yeah, that lines up. So we just add a breakpoint in here. We can see monster with 100 out of 100 health. That works. All right. So baseline structure is done. Now we add the attack. And for that, we're just gonna give the player super method attack monster. We're just gonna receive a monster. And to attack the monster, we're gonna add another method in monster itself, public void receive attack. and it's gonna receive some damage, and we just have to subtract that from the current health. And we should add that set, so we can actually change current health inside. So the get is public, we can read it publicly, but we can only change it internally in monster. So we can now call monster.receive attack, not like that, attack power. That means we can call player.attack monster and specify the monster. And if I set a breakpoint here, you can first see monster has 100 of 100, and then it has 90 of 100. So code seems to work. And this is basically the extent of what we did so far. Now let's talk about the first line of defense that has nothing to do with ensuring your code works in the long run and is just meant as a permanent solution whenever you write the code. These values are just straight up copied into the properties here, regardless of if they make sense or not. So I could also provide negative health. I can provide more health than the maximum. I can create all those weird situations where the monster doesn't really make sense anymore and potentially causes issues down the line wherever we use monster next. So we want to limit what a monster can be created with. We want to make sure that when we get a monster, we can be certain of a couple of features. We limit the values these two properties can have. At least the constructor itself will respect the data. We can talk about changes later on. And the classic solution to this would be an exception. We check current health, is it less than 0, which doesn't make sense for us. And health of 0 might make sense, like whatever mechanic we have for monsters, maybe there's monster corpse you can loot, and so maybe you want to spawn in a dead monster with a health of 0. That might make sense, so we're just gonna allow 0 health, that's valid, but negative health, that's not a thing. So we're gonna throw a new exception, and there's a classic type of exception for this, it's the argument exception. Specifically, we're gonna use an argument out of range exception. And I'm gonna be very specific. I'm gonna provide the name and the value and a message. The message is just gonna be Launch health needs to be at least 0, like that. And we get one exception if we actually try to provide negative health. So this case should throw an exception now. Okay, so we have the debugger running, so we get a breakpoint right now to show that there's an exception happening here. We just let the program continue. We can see in the output here, we did have an exception, plus our message. And the exception itself, we could catch the exception and evaluate the content, and we would see stuff like the actual value and can react to that in some way if we need to. Let's press on. There's another issue we want to catch. If current health is greater than max health. Actually, let's keep the logic with less than. Let's start with max health on the front and current health after. We're gonna throw another exception. Argument exception. This time we're just gonna use an argument exception. I mean, I could use an argument out of range exception, but I'm not sure it fits here because there's no specific range. Though it is a range, but it's a dynamic one. So I'm not too sure which one to pick in this case. I'm gonna just defer to argument exception in general. And I'm just gonna give out a message. Current health needs to be at most max health, like that. So current health could be fine, but if it's more than max health, we get another exception. And we're fine if those just line up. Okay, so these are kind of an assurance that we catch problems early on. We ensure that monster cannot be created in an invalid state. And we make sure that if something during the runtime of our program happens, so that we get weird values from somewhere and they get put into the constructor, we will throw an exception that notices the exact condition that went wrong and gives an appropriate response that we can react to somewhere else. At least it's logged, and the program will not continue executing with the flawed values. It will actually be forced to do something sensible. That's not helpful during the development itself though, because this is just a condition that will completely stop the program, or at least this part of the program. Plus, if you're performance conscious, putting these if conditions with exceptions for every single parameter and every single method, like for example, I might need to add something in here as well, that could potentially eat some performance. Depends on what exactly you're programming. I mean, this is not going to do much or anything at all really, this simple check here, but there might be sometimes slight performance issues if you have to create thousands of new objects, or if you have to run the same method millions of times per second and it's just full of if clauses because it has 5 different parameters that all have to arrange neatly next to each other. Yeah. Most importantly though, this is only catching a problem, so to speak. I mean, we're throwing an exception, but we're catching the issue, which is these values are not right. This doesn't really tell us where the values came from or why the values are wrong. It's just telling us it happened. And it will make sure that the program doesn't continue with the wrong values. Put a break in there, but we still have to figure out where did they come from. Let me just write a simple method here. Public static star create monsters and mount help. So we create a simple static method that will create an array of monsters for us. We need a large number of them, and so it's gonna make it very simple. Monsters. Oh, actually that was correct. Autocomplete. Yes. And let's try to be smart about this. Mount greater equal to 0, then monsters mount equals new monster help, and then we return monsters. Okay, this is maybe a bit weird to write this out, but yeah, I felt clever about it. So that's a feature too. Feeling good about your code. So here's code that we have that creates monsters, and there might be an issue in here where maybe this method itself has a problem and just passes on the wrong value, in which case the exceptions will tell us early. But maybe the issue is further up and someone calls create monsters with the wrong values. So monster.create monsters, let's say 2 monsters with a health of 100. So this would be the expected use case, which is perfectly fine. But maybe I made a mistake here for some reason. And here I'm passing on the wrong value, which then gets just passed on to create monsters, which then passes them on to the constructor, where we finally get an exception. This is a pretty short path down the road. We just have two method calls. Well, one method and one constructor call, but it's still annoying to debug this. And it's getting really painful if you have a large program where maybe your stack goes 5-6 layers deep or even more. So something you can do is you add another check in here. But I don't want an exception. That's a bit too much. That's a bit overkill. I don't want the code to break at this point because this method itself doesn't really have any issue with these values being weird. The whole logic about what is acceptable for a monster to have in terms of health, that should be defined somewhere else more centrally. At least for my current class, that is the case. Your system might have different requirements, and so the reasoning might change. But for me, all of that should be contained in the constructor. The constructor determines which values are alright. For example, maybe later I'm deciding that null is not acceptable either. Or 0 is not acceptable. And I don't want to change that here and in here, which just causes conflicts later. I just want to change it in the constructor, which is responsible for making sure that the values are correct. And this method should just pass on the value. So I don't want to have an if health less than 0 and then throw exception. That's not the job of this method. But I still want something in here that tells me early on that we got a wrong value. This is unexpected. So we have this little feature in the debug class, the same that also has the stuff like write line. There are plenty of features in here. And the one we're using now is Assert. We can just check health greater equal 0. It will just evaluate this statement to true or false, and the assert just expect either true or false, and if it's true, it will do nothing. But if it's false, like we will have now, it will actually cause the debugger, if it is running, to pause at the current location, as if we set a breakpoint in here. But we don't need to do that. It will just pause on its own, showing us exactly where the issue was. And it will also add to the output this little assertion failed message, plus a stack trace to show us the location. So I can continue also normally. It's not acting as an exception, it's not breaking the flow, it's just pausing and then continues. So you're not interrupted, it will just let the code continue. It's like an outside observer. It's not directly interfering with the flow, it's just giving us a chance to observe things happening inside. And so the exception will trigger. And we see that down here as well. With the exact message, current health needs to be at least 0, which it wasn't. We also have the assertion failed. Once you can see health greater or equal to 0, which is exactly the code I had in here, which is a pretty cool feature. I can also specify my own stuff. Else was less than 0. Could also do this. And now that's the message. So I can specify a message I want, if I want to, but if I don't, it will just use the code I added in here that I want to assert as the output message, which is pretty neat. Makes my life a bit easier. Combined with the stack trace, you can always be pretty sure where the break happened, even without a debugger. So let me just run this code again, but without the debugger attached. You can see it in the output here. Assertion failed, health greater or equal to 0. Slightly different. But they are very useful. You can sprinkle them throughout your entire code through various stages of execution. And it just gives you peace of mind that when you write your code, you can catch these little issues early on. The actual logic should only react where it's appropriate. So in this constructor, for example, with an exception. The logic up here doesn't need to check that value directly. It shouldn't care about the value. This Debug.Assert is just for you as the developer while you're developing, or while you're working on the code. It's just very useful. Because it's a debug method, it has a conditional attribute. Look at the code. Conditional for debug. So if I try to compile for productive use, but just switch to release, you will see this will get faded out because this is not actually part of the code anymore. If I run this now, which doesn't make too much sense. Excuse me. Ooh. It will not run this Debug.Assert because it's not part of my code anymore. So it's also not compromising your actual product later on in any way. You can safely add them. They won't add any performance issues or any additional bugs in your release code. They will only be present during your debug phase while you develop still. Very useful tool. I always forget to use them, but they are incredibly useful. Now let's say I have very good code. I'm confident it works. I have exceptions where appropriate. I check my values, and where I don't directly need to check my values, I still put in some asserts here and there, just as a sanity check mostly, to make sure I didn't overlook anything and to catch early if I introduce new issues. That won't catch anything. Not anything, not everything. There are a lot of things that might never catch because you're not really testing the functionality of create monsters here, right? You're just creating a little check that a certain value holds still up to scrutiny, that it's still valid. Or maybe you can make a simple check here, Debug.Assert monsters.length is equal to amount. So before you return the code, before you return the array, you could make sure that the amount is the same. But doing this throughout the entire code, everywhere, that's a bit too much. That's not what this should be used for. What you should do is just have a structured plan for these are the features my code has. I have a method, create monsters, which will create a bunch of monsters. And monsters are this thing that has two properties, which can only have these specific values. And now you should have someone test your code by just trying different combinations of values and seeing if they match what you expect them to be. Do they fit in the parameters you set out when creating the program? This has two benefits. First of all, of course, your code will be tested and any issues will be found. Like you just made a typo somewhere, for example, less than 0, and someone finds out, hey, I can't have a monster with type 0. Well, good, you found it. Fix the issue. But also, when trying to formulating these test plans, these little guidelines for what your code is supposed to do and how it's supposed to operate, you yourself will notice pretty early on if there are any logical fallacies somewhere. Maybe fallacies is the wrong term. If there are any parts you overlooked, any weird cases you haven't considered yet. So that's just rubber duck development, basically. You're trying to explain someone exactly how your program works, and suddenly you're faced with the question, is that actually how it works? How would that work instead? What did my code do? What did I want it to do? Sometimes those questions aren't clear from the beginning, so that's useful in there. But manpower is expensive and takes a lot of time, and well, often you don't have that amount of manpower or time or money. And so instead, you let the computer do the whole thing for you. Instead of a person checking your code, you write another piece of code that checks your first piece of code. Which means, of course, you can still make errors, but they will be less likely. And we're gonna create a new project just to show you how you potentially could do it. I want to preface, I'm gonna show you a very specific framework and a very specific tool I use to test code for my projects. This is not the best way to handle it. This is one of many, many possible ways to do it. And the only reason I'm using these tools is because they're what I'm used to. And most of the code I'm working with is reliant on those frameworks. And there's just no point in refactoring the entire code base that's many, many years old by now, with so much code on there, just to switch to a different framework. It's better to just stick with what you have, which works, which has proven itself, and just expand that. Also, I can just select a test in here and create a test project directly. There are different options presented to you here in the standard dialog for Visual Studio projects. I'm just gonna go with the class library though and add the necessary nugget packages myself. Yeah, that's fine. Let's just delete the class first because I don't need it for now. I'm gonna add 2 nugget packages. The first one, the big testing framework I'm gonna use, is a unit. Oh well, that works. Just gonna install that. It's in, and I need the test.SDK. Yeah, that should be it. I typed it in earlier already, so that should be it. Microsoft Net Test SDK. So these are the 2 nugget packages I have in here now. Okay, don't like that. Let's put that out and enable warnings as errors. Okay, so this project will now allow me to create unit tests. And they're... Okay, honestly, I'm abusing the framework a lot, usually, because why not? A unit test would basically be, ideally, I'm just picking one small component of my code and write tests for it. I'm writing code that lets the computer know how to use the method and which ways to call it, how to check the values, how to evaluate what changes it does to the outside world, to the class it's in, to other classes it might be connected to. And that's just one small, ideally isolated part of my program, and I'm writing the same style of test for all parts of my program independently. So I have tests that check specific small components in my code, ideally down to just a single stupid method, and that will make sure that from the ground up everything is just correct. Doesn't always work that way for many reasons. Plus, it's not the only test you should do. But the framework allows you to do quite a lot of cool stuff, and you can abuse it for things that aren't strictly unit tests. Or it may be that you can call them still unit tests, but they're bastardization, and you're not really following clean coding. Doesn't matter, it's just a tool that you can use for tests. Let's put it that way. Let me just show you instead of talking. Let's call it tests. Just a new class. Internal, that's fine. And the first thing we're going to do is we're going to add an attribute to this class, TestFixture. Basically, we are marking this class as a test class, as a class that contains code that needs to be run for the tests. So as in code that is our test, basically. And now in here, we can write a method, many methods actually. For example, public void create monster. I can give it any name I want, doesn't really matter. But I should give it a name that sort of represent what kind of tests I want to happen in that method. Now I have to also mark it as a test method. Like this represents code for one specific test. I can also have another method, public void damage monster, which would do a different test. These are two different tests now that are run independently later on. And to run them, you can use the built-in tools for Visual Studio or whatever other tools your operating system or your IDE has or your built environment. Just gonna stop it here. So Visual Studio has built-in test tools. I don't really use them. I rely on resharper tests. That's what I'm used to, but either works or entirely different set of tools or extensions for Visual Studio, whatever else you have. You can also see the list down here. You see the little green check marks because all the tests passed. That means just it ran all the code in our test fixture, all the tests, all the simple methods in here. I didn't need to create a console program for that. I don't need to have any console program and hit debug up here or run or something. I just define the different methods. They're all decorated. That's the term I was looking for. Decorated with specific attributes that belong to the nunit framework. So this is from nunit. We're not gonna import a TestFixture as well. Attribute from nunit. And in this case, Visual Studio or resharper both recognize the attributes, recognize the assemblies, and know these mean it's unit test. This is for testing. So I can just tell the system, please run all the test code, and it will basically create an instance of the class and call the different methods in here. And if the methods just execute fully without throwing any exceptions, well, then that's a success. Test passed. That's it. We can tell them to do something internally that might cause an exception, a very specific type of exception. For that, I'm going to start with just a simple creating a monster. Monster. Oh, right. I forgot I have to add a dependency to our other project. Now it should work. I had to import it now, but monster. Let's remove this. Can create a new monster like so. And I can also just test this specific method alone. No exceptions, that worked. If I were to cause an exception, for example, I provide a negative value, which means the constructor itself will throw. Well, for one, the test failed. Get a little mark here that goes up the entire stack. So we know somewhere down here, something failed. Can look at exactly what failed. And we look at the output on the right. This is the exception we got. Which, yeah, that's the exact exception we throw in the constructor. And was in this test where the exception happened. But just throwing exception, that's not what we actually want. we want to know if it does throw an exception when we provide the wrong values, but doesn't throw an exception if we provide the right ones. So even though this does throw an exception, we wanted it to throw an exception. This is what we expect to happen. So we need to tell the system now somehow to call the constructor for monster, deliberately giving it false values, and making sure that we do get an exception. That's the expected behavior we want. And to make sure that stuff works, there is Assert. There's an entire class for that. It's also called Assert. There's no direct relation to Debug.Assert, it's just a common useful name for testing. And for nunit specifically, there was a change a while back in the style of asserts. So the ones I'm used to, that we're still using in our old projects, is now actually called Classic Assert, where we had a bunch of different methods that would check different things. With the new style, it's just all in Assert, and I'm gonna try to use those, but I have not much experience so far. But the first thing we're gonna do is we're trying to assert with a catch. The catch is a specific method in Assert that we can use to call code and check that the code results in an exception. The concept might be a bit weird, but you'll get what I mean when you see the next part. First thing we're going to check is for argument out of range exception, which is the exception we throw, the specific exception we throw when health is less than 0, or current health. And in here, we basically put a lambda expression. This expects a delegate of sorts, and we can just call the constructor for monster in here. -1, 0, or 1, whatever. This constructor is expected to throw an argument out of range exception because we have a negative current health. So this code in here, this expression, will throw if everything works as intended. And this method will recognize there was an exception thrown in here, and it was indeed an argument out of range exception. Everything is good. So it will throw, but this Assert.Catch will catch that exception, and the test as a whole will check off as success. So we specifically instructed the code to throw an exception. We deliberately caused an exception, but that was okay because we wanted to make sure that the code does indeed check that the current health doesn't fit the criteria. Example, maybe something happened and we made some weird checks here. Suddenly it's just check for, well, it's -10. Or maybe we deleted the thing. Heck. Maybe we just swap this around. Let's put it that way. Monster will not throw an exception anymore. And now it complains that we expected an exception, but there was none. Go to the code again. We want to assert, we want to make sure that this code throws an exception of a specific type, argument out of range exception. It didn't. That means we have a problem. Not throwing an exception is exceptional. So we get this test flagged as failed. Let's go back in our code and correct that. Sum this back to less than. And now it will throw an exception, and test succeeded. The code behaved as it was supposed to. We can do that again for normal code where everything is correct. 100 current health, but only 1 max health. Actually, let's go with lower numbers. This will throw an exception, but it will not throw an argument out of range exception. And that is also a problem. Throwing the wrong exception means that something didn't work. Either the code was wrong, or the test was wrong. But in any case, we have to check that out. And yeah, max health less than current health, that's an argument exception, not an argument out of range exception. We have to be specific here. Technically, argument of range exception is an argument of argument exception, but it's not specifically that, so we have to account for that. Test again, and yeah, both constructor calls result in an exception. In their specific expected exception, everything works. We can also just go back to just creating a monster. And let's go with 100, 100. This should not cause an exception. We just leave it as is. If it were to throw an exception, we would know the test fails. We tested that earlier. What we can do now, however, is check that the monster has correct values. The monster current health and max health match what we wrote in here. And that's what the asserts are for again. And for the newer style, we use Assert.That. Assert that something is true. And first, we will introduce monster.current health. So the value we want to test, we want to assert that this value has something specific, some property we're looking for. And what we're gonna check is equal to 100. This looks a bit weird, maybe to you, but it's perfectly legit. It's just, we call a class, or we call a static method inside a class. The class is just named is, and the method is called equal to. And you don't have to think too hard about how they made this work. It's just a bit trickery. Like, this internally returns a specific data type that's expected in the that method that is evaluated internally later on. Let's not get too deep into it. It's cool trickery, but it's just trickery. In the end, it's just so you have it easier to read what's going on. Assert that current health is equal to 100. So basically, they wrote it in a style that makes it easy to read out. Like, if you just read it out, it sounds like plain English description of what this test is. Assert that monster.current health is equal to 100. I'm just reading what's here. And it's the description of what it is. So that's pretty cool. The old system, the one that I'm used to, would have just the assert. Like, now it's called classic assert, but in the old versions of InUnit it was just assert. The new functions didn't exist like that, and I would have r equal, for example. I would check 100 are expected, but the actual value is monster.current health. This is what I would get in the old system. Also pretty straightforward, but you have to understand what you're doing here. It's not as clearly spelled out, if that makes sense. But it's less to write. And it's quite convenient to go through just IntelliSense to figure out the exact method you need. I want to check equality, so look for equal with IntelliSense, that's quick. Now I have to look up the library to check, okay, is it, okay, it was the class is, and there I have to use IntelliSense. And then sometimes you have to combine that with other values, because you can extend this as a chain. You can combine this to a full statement. Again, it's trickery in the background. It's pretty cool stuff. I like that kind of stuff. It's just maybe too much for you for now. It's not that you wouldn't understand it. We talked about the basic technology behind this, but I mean, you could recreate all of this yourself. You technically have the knowledge. It's just weird to see it in action sometimes. I digress. We want to check current health and max health. So we check that the wrong values will throw an exception as intended. And if we give it proper values, we make sure that they are hold in here. That the values we create the monster with are the actual values we will get back later once the monster is created. So this test might not be the best. See, I could just have a little error in this code and suddenly this code will still say, yeah, success, create monsters correct. So when writing the tests, you have to try and be a bit clever. So for now, I'll just change this to 99 to make sure we have different values here. And if I test it again, we will get actually an assertion fail. Max health is equal to 100. Not quite. Let's check it out. Oh yeah, we made a mistake here. This was supposed to be max health. Max health. Okay, now it's corrected. So you can make mistakes in your program. You could also make mistakes in here. Could also check max health in there. I can pick wrong values, which is not directly a problem. It just makes your test less useful, or make you accidentally think that your code is correct because the tests all succeeded, but it actually just hit an error. It might give you a false sense of confidence, I mean. And you can have actual errors in your code in here. So it's still code you write yourself that can have the same issues you have in your code that you test. But it does add a lot of safety, because now you have to basically implement the logic twice. First of all, we check that the exceptions are there, and generally the monster can be called. That's good to know. Let's extend this a bit by checking functionality of the monster. 100, 100. And now we want to show that monster.receiveAttack will actually reduce the health of the monster. So I'm just gonna copy the code from here. I'm gonna make sure that the actual health is now 90 after we damage it with 10, and max health should still stay at 100. Why am I including this? We only want to check that the current health is 90. Technically, this is all the test should be. I know what type of errors I make, so I also include the line with max health, because one of the biggest errors I might make in a method like this is changing max health. Sure, right now it's not possible, but maybe I have later on some ways to change the max health as well. And I don't want to accidentally change this. So I'm just gonna add a layer of safety and preemptively add the second test, which I suspect might be the error otherwise. I mean, current health wouldn't be reduced, so this would trigger first, but I mean, you get the idea. I'm just adding a bit of extra code to make sure that errors I expect didn't happen, additionally to the actual check I should be making. If I just run all the tests again, constructor is still fine, my damaged monster is also success, everything worked as expected. Actually, look, you know, let me do the actual code. This would be the more correct one. I'm just testing if damaging the monster works. Only that logic. The monster has 100 health to begin, I damage it with 10, it has 19 now. That's the test. If I want to be thorough, I should make damaged monster who doesn't change max health. Yeah, let's ignore that. And same setup, just testing that max health didn't change. So if I did want to make it correctly, I would have to make a separate test to make sure that the same effect that I did here for damaging the monster didn't have this weird side effect that I was expecting. So me putting that up in here in the same method is just being lazy. But it's technically a different type of test that I should put in a different method. It's just more to write. Which brings me to another issue you might have with unit tests. That it's one of those things where, strictly speaking, you shouldn't do it, but sometimes it's just you can't not do it. It's just right now I'm constantly creating monsters, and I suspect if I'm doing some more tests with monster, I'm probably gonna do the same line creating a new monster every single time. Right up here I had a unique variant of creating a monster where I had different values, but these two lines are the same, and after what we're gonna do, maybe there are more lines that are gonna be exactly the same. So I might just end up make a simple method in here, private static monster create monster and health, and that returns new monster health. It's a simple example. I mean, I'm just calling constructor. I'm not doing much, but maybe creating this instance is a bit more complicated and requires a lot more parameters. Maybe reference a couple of things, maybe include some obscure steps to create and things to be aware of. And so instead of writing all that code out in every single test, I might just create a simple method that does all of that for me. So I have less code to write out. You might be very tempted to do that at some point. This is not a good example because this is pretty easy already. I mean, it's a bit less to write. Plus, this way we can easily change our code if we add another variable in here, like max health bool green. So we have a new parameter that says if the monster is green. What good that will do? Doesn't matter. Well, our unit test, I can just go false on here, for example, to give a default value, and these two tests just work. They don't care. They don't care that monster changed. This test up here did change quite a lot, because all of these constructor calls don't work anymore. So creating a custom method, especially once it gets more complicated, is very, very tempting. But that all the different constructor calls break is actually kind of feature. Well, not intentionally, but it is quite useful in a way. Let's just return the code to what it was before. Because remember what we talked about when discussing libraries and compatibility and the obsolete attribute? If you write a library and you add a lot of unit tests that check the library, creating instances, calling methods in there, you automatically have an example of code that uses basically all your features. So whenever you accidentally make any changes to your library, changes that might be code breaking to someone else that uses it, you will know immediately, because your own library that is hopefully targeting everything your library has will break. Your unit tests, without even running, will let you know that you made a reference in this code to a library method somewhere. This method call doesn't work anymore. And if it doesn't work for the unit tests, it will not use for someone else that uses your library. And that's your cue for, I should add some backwards compatibility. I should probably mark the old one as obsolete, or find a way to implement the feature without changing the signatures at all. It's also a way to make sure that any major changes are caught early on, even if the signatures didn't change, because your unit tests might suddenly behave weird. Like maybe you decide that, you know what, having more health is okay. There's a max health, which is now just referring to a default, but not the actual upper limit. Well, in that case, this test will break, which is fine. It's not it's not because your code doesn't work anymore. It's just because your unit tests is still working based on the definition for your old way of doing things, for the old library. When you create a unit test, you write down in code how your library is supposed to behave, the rules, the features, the limits, everything. If you change that somewhere, your unit tests should suddenly fail. At least one unit test will, if you do your job right, suddenly not work anymore because you changed the limits, you changed the boundaries, and it suddenly noticed it. And now you have the job to determine, was that a good change? Or was that a mistake? If that was a mistake, you can go back and fix that. Oops, didn't mean to delete it, put it back. If that was intentional, you can go in and just remove the line from your unit test. And from now on, the unit test will use the new definition for your code. You now allow max health to be less than current health. But you are forced to change the rules manually. You are forced to remind yourself you are doing something that will change the behavior of your code in a specific way. Let's talk a bit about edge cases. Right now, creating a monster is using one example, which is perfectly fine. It's a pretty good cover-all solution to make minimal effort to catch most of the issues. Like most of the time you create a monster, it will work similarly to this. Either the same value or value less than that. But there are interesting cases where, for one, what's about the situation where both are equal? Did that have any weird side effects? Do you have any conditions that are strictly about being equal or not equal? What about 0? Is there any specific meaning to 0? Those are values that are right at the border between that's perfectly normal and allowed and actually this is a problem. Right at the edge between the two worlds of that's okay, that's not okay, there are the edge cases where you have to be careful precisely what combination of values is allowed. And sometimes those edge cases are not as easy to pin down as you might think. Now for us, luckily, we're working with integer values and just 2 of them, so we can be very precise. So I'm saying less than 0, that's perfectly fine. Maybe I want to change this to 0 as well. Well, my tests will not react to that. That means my tests aren't good enough yet. My tests should reflect somehow this change in behavior, because it is actually quite a significant change. I moved the border, the exact border where values turn from invalid to valid, over by 1. The border moved. There are now values that are no longer valid. And I should have a test in line that suddenly breaks. Lets me know that, oh, the border moved. Was that intentional? Did I do that on purpose? Otherwise, if I didn't do that on purpose, some code might break. Some other code might expect the old borders to still hold, and suddenly it breaks, and you might not find the error because it's just trickling down into the entire program tree. There's no perfect solution for this. Writing good tests is a lot of mental labor sometimes. And honestly, there's a reason people can get entire degrees basically on testing. And just how to approach testing, how to write meaningful tests that cover many, many different topics, different issues, different kinds of issues. I'm just here to tell you that writing good tests is hard, and there are some simple things you can always look out for. And we're gonna introduce another feature just to make our life a bit easier as well, and so you can see it. Test normal monster creation. Create invalid monster. We're just gonna rename this. We're gonna move out this code. This test up here is now just checking for invalid values. And we're not gonna touch the add case in there yet. Just gonna ignore that. And instead we're gonna have a separate test just for going through the normal stages a monster might have. The normal values we expect and some edge cases. The simplest way to do that would be just, okay, let's try 0 and 100. And then maybe try 0, 0. That seems like an edge case. What about normal 100, 100? They're both equal. Still valid definitions, just the value itself has maybe potential to break something. There's something unique about the specific values you chose. We have one example for something that seems quite mundane, but then we have cases where current health is exactly 0. And we have cases where max health is also 0. And we have cases where max and current are equal. We could also go further and just test, hey, what about the maximum value for an integer? Max value. And yeah, I should also adapt this 100, 100. One too many. No, not that. Like that. Make sure that works, because maybe we're trying to add something anywhere by exactly 1. That's a common issue, off by 1. You input a value and internally it's used by 1 less or 1 more. And so testing out the maximum and minimum value, that's common. Minimum doesn't matter to us because that would be less than 0, and that's a different topic entirely up here. Okay, this looks good, but it is also a lot to write out. And it's another point where making our life a bit easier seems good. Why not simplify this in a loop, for example? Just make a loop that goes through all these different values. That's possible, but that also means you have to add extra code in here. For example, like so, by adding a message in here that includes which iteration of the loop did we run to the issue then? After how many iterations of a potential loop that goes through all kinds of values did we have the issue? So we can replicate the problem. So instead of doing the loop ourselves, we relegate that to a function in the unit framework. And we're gonna use a different attribute. We're not gonna call it test, we call it test case, which actually gets values from us, just arguments. And so does this method. And let's just use shortcuts because I'm lazy. This method gets 2 values now. One is used for the current and one is used for the maximum health. And we can just reuse them in here. Current max. And we can now write a test case that receives 99, 100. It receives two arguments that are used directly as arguments in this method call. So let's just try to run all our tests again, just to see that all the other tests work as well. It worked out. And if we look at the tests, where we have the test case, test normal monster creation, we actually can expand, and we can see down here, normal monster creation 99, 100. We see exactly which values were used to call this method here. So we also know which values were introduced into the monster constructor. Let's add another attribute. Another test case. With 0 as current. If we look down here, I have now two test cases under the overall name umbrella test normal monster creation. This one has 0 and 100. I can run the test as a group and it will test both of these combinations. And we'll see this one succeeded, but this one failed. And that's because I still have the equals in here. Let's return this back to 0 and try again. Now it works. Let's add some more test cases. So 0, 0 and max value. Let's run them all. All of them succeeded. So all of these combinations did fulfill the limits we pose on monster. All of them could be created, none of them caused any exceptions, and all of them were saved exactly as intended, so no cutoffs or anything. Can do even something more interesting. Now this next one isn't necessarily a good one, but it is interesting. So let's say we reduce this to one value only, health. We're gonna use the same one for both. We're just gonna test if different integer values maybe hold weird side effects. We're still gonna test if they're both used exactly as intended. Actually, we can skip this one, we don't care about that. We have this other test that already makes sure that the values are copied over identically. We just care about, does this cause an exception? We don't even need to store monster anymore. Now here we add an attribute to health directly. Oh, I should mark this as test as well. Of course, this is a normal test now. And we have an attribute values, which can receive a couple of different values now. And I could go 1, 2, 10, 100, and dot max value. And I can run all of these. Test specific health values. Let's rename that maybe. This makes more sense. Okay, now it's not hidden anymore. Now you can see all of these get used up. So I could write test case out, or I could write the values out. Well, let's try to use this as current, and let's do the same here for maximum. So now we have the same combination of values for both. What happens here? We have 25 different combinations now. Each combination for the current help is combined with each variation for maximum help. So of course we get some issues here when max value is less than current. So that's why I said it's not the best solution, not the best one to pick. But if we did accept different values, this would be a pretty good solution to quickly test all kinds of combinations without much writing to do. There could be hundreds of tests, thousands, millions. Okay, maybe that's a bit too much, but you can have all kinds of combinations happening here. Can test every combination of inputs and see if they worked. And you don't need to write by hand every test out. So there's still some automation happening, but it's all communicated to the test framework, so it still helps you out with keeping the different tests separated and keeps track of each one specifically, each one on its own. There's no case of you writing custom code to make your life easier and maybe messing up the loop that is supposed to iterate through all of them. So there are some automations that are included in the framework, and you should make use of them. There are some things that might seem annoying doing them by hand, but they have benefits. Like creating out the constructor by hand, even if it's a multi-line process with lots of different values to take care of. It might be better to write them out one by one in each method on its own, even though it might seem like that's bad coding. That's maybe the best advice I got for unit tests. They break the normal rules. If you see code repeating over and over and over and over and over again in thousands of different methods, of course your instinct will tell you just write one method that takes care of this one thing and reference that one method everywhere. And that's usually a pretty good idea. If there are many lines of code that are constantly repeated, it's very, very likely that at least one of those different code blocks will have an error, the others don't. And it might be hard to track that one down and annoying, especially if you have to suddenly go back and make the same edit in many of these other code blocks because they all have the same kind of issue, it just never came up. So combining them in one method somewhere else makes your life a lot easier, makes it easier to maintain. For unit tests, however, this does not apply. You want all the methods to be on their own. You want them to break individually. If one of them breaks, you fix that one unit test. Because each unit test represents a different context, a different scenario. So even though the code looks the same, it might have a different purpose. And you have the issue of if you centralize the code and you make an error there, all unit tests that use that one location might also share the same error and test wrongly. Not the code breaks and everything suddenly has a fail. That's not the cause of concern here. It's you make a mistake in the centralized code that you just reuse through all your unit tests, and you get a success everywhere. Your tests say perfectly fine, your code has no issues, even though you have some glaring problems because you have one additional mistake in your test code, and that hides the original mistake. That's the biggest worry. Unit tests are weird. I mentioned earlier, creating instances might be a bit complex. You have to maybe instantiate other things and have to go through some hoops to create the instances, and that's why you might want to put them in a constructor call somewhere else. Let's assume I want to test the monster's interaction with a player. But I don't want to constantly create new players in my class that tests monsters. That's not the point. We assume that tests, let's just rename this, or monsters. This class is just for monsters. We organize things. We have another class that tests player. And in theory, you should maybe add a third class that tests the interaction between the two. But let's say we want to add some tests in the class that tests monster. That allows us to check how a player reacts with the monster. So we need a player. But constantly creating a new player, that's a bit annoying. I always say annoying. Player damage test. Well, constantly creating new players, that might be a bit too much. Our player is pretty simple, so we're not losing too much time. But why create constantly new players if the focus is the monster? Make a smaller one this time. I just want to test player.attackMonster. Then wants to check Assert.That monster.current health is equal to 10 minus 3. I'm just going to write it out by hand. The compiler will put that together to a 7 anyway. So when the code is run, it's going to be 7 directly. But this way it's more clear to me as the one reading the code that I'm referring to current health minus the attack power that I defined up here. So let's say I don't want to create players all the time for tests like this. Where do I get a player? Well, I can. This is a class after all. Add a field, private player, and use the same player all the time to attack my monsters. When do I create the player? Do I have a constructor? I mean, yeah, I kind of have a constructor, sure, but creating the player itself might pose challenges, and maybe it involves the monster as well. Maybe you have to create the player in combination with specific data that refers to monsters that is potentially interesting for testing itself. So instead of using a constructor, you use a special method. Public void initialize. Always have to worry about how many eyes are in there. Initialize. Yeah, let's just call it initialize, whatever. And to mark it as a special method, we give it another attribute. And the attribute we're looking for this time is a OneTimeSetUp. Because it's setting something up once at the very beginning, before this class is actually going to be used. We're going to assign a value to player equals new player, attack power 3. Like that. Right, let's put it like that. Player is nullable, so we didn't add it in the constructor, so player is technically null to begin with. And also means I have to actually do this, or more specifically, I could also do this. Because I already made sure that my code will, if it follows the normal logic, make sure player is filled beforehand, so I can assure the compiler I took steps to make sure player is not null at this point. You could just go for the null propagation here, null coalescent, but simple assertion, this is not null, is fine. Let it break if it breaks. And now, when the tests start, before it does anything, it will call this method here, the OneTimeSetUp method, execute code in there, and only afterwards will it start to execute the test methods, all of them. There's also a counterpart. For example, if player has some special properties that requires to dispose it specifically, or do some special code in there to clean things up, or do something else entirely. Cleanup, let's just call it cleanup. There's a OneTimeTearDown counterpart. So the OneTimeSetUp is the method that's called before the tests start, and the OneTimeTearDown is a method that's called once after all the tests are done. We don't need it right now, so let's leave it like that. But I can just call the entire class now again, run all. Calls all the tests. And we have a bunch of good tests, and we have some tests that failed, which are all the specific health values because the combinations don't work. So let's just remove this. Don't care about it anyway. Let's just retry all again, and now it works. The easiest way to fix a unit test is to delete it, unfortunately. And quite often that is your first solution, especially when it's 2 in the morning and you've had enough of 6 hours of debugging and still can't figure out why the test breaks, and you just wanted to compile and allow the pull request to go through. Luckily, I never had that situation. I just started the next morning and try again to figure out what the issue was. Because if you're working late at night and you're banging your head against the wall, you often can't see the issue right in front of you. Because you're stubbornly looking for the same error again and again and again instead of getting a fresh idea. So sleep is good. So yeah, player gets created here once to attack the monster. What if attacking the monster has side effects though? Let's quickly introduce that. Monster effector, and then attack power is minus. Yeah, let's make it private set again. Let's say every time we attack, it makes our attack weaker afterwards. It dulls our sword. So if I were to do another method where the player is involved, I would get a different result purely based on the player, the same instance being used before. Because I'm creating one instance of player once before I start my tests, and the same instance is used throughout all the tests. But it doesn't stay the same, the player changes over time. So the order in which my tests are executed influences the test result. Now technically there's a way to round that. You can, I think that was order. You can specify numbers to each test, so you can make sure they run in sequence, in very specific sequence. But what you should do is make sure that player either stays the same, or you use the same player again and again. And here's another part where you can make automation work by including that in the framework's rules. Actually, let's reuse this. Instead of using a one-time setup for this method, we're using just setup. The difference being, a one-time setup is called at the very beginning of all the tests for the class. But the setup method is called right before every single method, for every single test in that class. So this test setup will be called, let's see, 1, 2, 3, 4, plus 4, 8 times in total. And every time we create a new player, stored in this variable and on this field, and it can be used. So even if another test already used the player, when your test starts, you get a fresh player. So all the tests use the exact same starting point. You can do a lot of other cool stuff with that as well. I use it, for example, for logging, because a lot of the code I use, at least for work, involves loggers in the background. And sometimes we have to work around classes needing an active logging system running in the background because they refuse to work if no one is listening to them talking about their issues. so we have to add a mock logging. But we also want to keep the log files themselves because they're useful in case something does not work. So we have to use mock logger, so to speak, that we introduce to the classes. So they use that for normal logging. They think it's the normal logging they expect during runtime that just stores something in files. But actually it redirects it into an internal data structure during runtime. And before and after every test, we have a setup and its counterpart, which also works for every test, the teardown. Not the one-time teardown, but the normal teardown. And they just make sure the buffer that contains all the logs is cleared and evaluated before and after each test. So that's a pretty useful way you can use them. And of course the one-time setup to prepare a field if you don't want to change the code to recreate the same instance over and over again. Again, this is a test for monsters, not for players, so there's no point in specifically writing the code for players again and again. The code for monsters, sure, we should do that by hand in here, but creating a new player, that's not of concern for this class. That part is fine to automate. But ideally you do that in a context of the framework itself, using something like the OneTimeSetUp, which allows you to also include asserts. Maybe you should. So like that. We can also assert in here, Assert.That player.attack power is equal to 3. So we can make sure that guaranteed the player does exactly do what we intend to. So that worked out. If it didn't match the value, let's run all the tests again. All the tests fail because the initialize failed. Which sometimes is a bit weird to find out. Oh, there we go. So these ones just say failed. If we look at the tests themselves, they will complain that the assert failed in our initialize. Okay. And only one last thing to show. This is not directly a feature that's relevant for unit testing, but it's one where it's very, very useful. Let's say, for convenience sake, in my library internally, I have a function to quickly reset a monster. I'm just restoring it to full health, because maybe it's an asset I had to load into the game world, and that's usually requiring a lot of resources. So when the monster is defeated, instead of getting rid of all the data that's already loaded into the runtime, into the memory, and spawning in a new monster, and just take the old defeated monster data, but whatever, and just hide it somewhere, then reset it to just fill up the health again, and then just place it somewhere else in the world. You recycle the existing data instead of creating new data and having the memory management take care of the old data first. You save so much on resources, and I do that by just using the reset method. But I don't want to use someone outside of my library to use that method. Maybe there are some specific rules around this, or maybe because it's just a simple method that doesn't have much in terms of checking if the values are correct or if there are any side effects. Because it relies on only I can call the method, and I'm the one that wrote it, I know how the rules work. So I hide it from outside users by making it internal. Meaning I can make a test, reset monster. Let's just use a normal monster. Here we can start with monster that has 1 health out of maximum 10. And I want to do monster.reset. I can't do that because it's internal, so the compiler will complain. I would like to check that it is equal to just 10 later on. The way around this is by allowing internals to be seen by this other project, by our unit project. It's the only time I use that feature at all. It's only for unit tests, but there are other applications you might have. And that works through an attribute. And this attribute is quite special because it doesn't apply to a class or a method or an argument or anything. It applies to the entire assembly as a whole. And that works by having this structure. You just have the square brackets. You started with assembly and colon. And this basically tells the compiler you're applying an attribute now to the assembly as a whole. It's a bit weird to get used to first. You can place that anywhere in your code. I just placed it in the only source code file I have, and I placed it above the namespace because I didn't want it to accidentally be associated with it. You could also make a completely new CS file and include this stuff in there. I mean, that's what .NET Framework does all the time anyway. And the attribute we're looking for is InternalsVisibleTo, which does exactly what it says. It makes sure that the internals in our assembly right now, like this reset method, are visible to another assembly. Even though that's against the rules, we make a specific exception for one specific assembly, and we do that by name. We have to give it the name of the assembly that is allowed to see it. And that is now unit tests help. Now, I want to be clear. This project that we're working on right now, where we add this attribute, has no idea this other assembly even exists. There's no relation to that other project, to that other assembly. We just told the compiler, give it the attribute that internals are visible, and nothing more. And now the compiler in the other code will see that attribute, will see you're referring to monster.reset, and it will see monster comes from an assembly that has this attribute, and it will notice the name in that attribute is the same as the assembly we are in currently. And so the compiler will allow you to call the method, because technically it is there. It's never an issue of when we compile it, the reset method doesn't get included with the code. Even the private code gets included because it needs to be there. During the runtime, those methods get called, but they're just hidden to other assemblies. And with this, we told the compiler it is fine that this other assembly sees the internals of our first one. So now we can reset this to 3 to make the code work again and just run all our tests again. And it worked, including reset. And if you're worried about someone else abusing this to suddenly get access to the internals, first of all, there are other ways to get access to internals, so this is not going to protect you just not using this. But if it's really bothering you, you can always just use the recompiler statement and then make sure it's only included during debugging, which is probably where you're going to use the unit tests anyway. And then once you make the release build, the attribute is not included anymore. So that is how that works. And that's an unit. In theory, I could maybe talk about code coverage a bit, but that's actually a large topic. It's also, I would need some really good examples to demonstrate the different types and why they are used. And I can't think of any good examples right now. I would actually need to construct some. I mean, I could make some very simple example. No, that doesn't. Not worth it. Anyway, to recap, exceptions, very useful, but they should only apply in specific parts of your code. not in every single method should you check everything the method might receive and is going to use. That's overkill. It's not the purpose of a method to check all kinds of values again and again and again. It's not your guard dog that catches any error in your program anywhere. It has one specific purpose and it's only supposed to do that one thing. And the exceptions, like these, make sense in some methods, like the constructor here, but not in another method that calls the constructor. There's no point in it. Why bother with exceptions down here if you add them to every method that might call the constructor? That's just not feasible and makes for badly maintained code. So instead, to help you catch errors, you can use something like Debug.Assert, which you can include everywhere where you feel like, this is a bit uncertain, I'm not too sure about this code. I just want some kind of observer that keeps me informed if something happens. I don't want it to interrupt the code, I don't want it to throw an exception, I just want to know if it happened and be able to interact early before the error gets moved further down where I lose context of why the error even came to be. And then beyond that, you can start using test frameworks, like frameworks for unit tests, one of which is nunit, which is not the only one. There are many other types of testing tools. There are also many tools or frameworks for unit tests. This is just the one I'm used to. This is also the tooling I'm used to for unit tests. It's not the only one, and there's nothing specifically good or bad about this one that I know of or special. Use whatever you have available. And for nunit specifically, you write a specific test class that includes different test methods, where each method is supposed to recreate one specific part of your code, to run it and see if it holds up to your expectation, if it produces the correct results or if it follows the correct behavior. And there are various ways you can make your life a bit easier. Instead of writing everything by hand, you can use some automation in the form of things like test cases and having automated iteration for different values and using special initializer methods that help you reduce boilerplate code for cases where you don't need to test it. And in the end, those methods all use just asserts, again, but a different type of asserts that really just focus on one very specific aspect, tell you if it worked or not, and potentially fail the entire test if it didn't work out, and just continue for the next check if it did work out. That's testing. At least the testing that you should be familiar with. Side note, things like the unit tests and frameworks like nunit are pretty widespread, and there are a lot of tools that kind of have the ability to hook into that. So you can have automated build setups that not only build your code, but then automatically run all the tests and immediately tell you if there are issues. There are also systems where if you have a complicated build and it takes a bit of time, and testing is a complicated process that takes a lot of time because you have millions of tests, you can have systems where maybe you have some source control and you have some big changes you want to merge into a new branch. Well, you just have the tool, an external program, get all your changes from a Git branch, try to build it, verify that it works, then run all the tests, verify that they all pass, and then merge it with your new branch. Stuff like that is possible. It's very useful. It's a bit more advanced, but it all relies on you writing good unit tests or whatever else you're using for testing. Right, homework. Try to figure out how your specific development environment would handle testing, what options you have in general, and if you have the ability to use unit tests, try to figure out how that works and implement them. If you have something like Visual Studio, you will have definitely built-in test tools. Testing is available. And if you want, you can create a new test project with NUnit or whatever else you're provided with. You can use the default templates for test projects you provided with by Visual Studio maybe to begin with, to make sure they are compatible with their own testing system. And then try to write some tests for a piece of code you've written in the past. And come up with some good tests that really make sure the method always works and that will react as soon as you make any changes to your code. Just to get a feel for what can you do with unit tests and how to make sure I'm effectively testing my code. Just get more practice with it. Right, that's it. Bye bye.